Hey everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this problem. We are required to simplify this algebraic expression. Okay, perfect. But given the condition that -1 is less than a and a is less than 0. In other words, a is a negative number because any number less than 0 is a negative number. Okay, we have this expression and we can start by working on this denominator or on the side. That's entirely up to us. Okay, this expression we can keep square root of 1 plus a over square root of 1 plus a minus square root of 1 minus a. But this problem we can work it here. What happens if we factorize the negative here? If we factorize negative sign there, then what's going to happen? We're going to have 1 minus a, because if it enters becomes -1 and if it enters becomes a +1. Now after factorizing it, we have square root here and we have a square root here, but in this denominator we have square root only in one, but we don't have here. What if we implement square root? But the problem is, can we implement square root without checking if this number is a positive number or it's negative number? According to the condition, a is less than 0. So if a is less than 0, that means a is negative. So if a is negative, that means minus a is a positive number. So that means there is no problem if we implement square root 2 and we say to the power 2, because they can easily be simplified and 1 minus a won't be affected because it's a positive expression. Since a is less than 0 and minus a, now it means that it's positive, right? Okay, now we have this expression. If we look at this side, we have 1 minus a squared, which is a difference of 2 squared, which is 1 minus a plus or times 1 plus a. So we can transform this expression into square root of 1 plus a times 1 minus a. We can transform into this expression. And on top, we can simply put another square root and say all to the power square 1 minus a, as the same here. It is a positive number. Okay, now so we're going to have square root of 1 plus a over square root of 1 plus a minus square root of 1 minus a plus. We have square root of 1 minus a, square root of 1 minus a, we can factorize. So we're going to have, factorizing it, we're going to have square root of 1 minus a, factor, here will be left with only one square root of 1 plus a, and here will be 1 minus a, okay, times this expression. In this expression, we can work it out. This is 1 over a plus, here we can cross multiply, will be square root of 1 minus a squared over a squared. Okay. Now we can simplify this 2 with this square root. And now they will have the same denominator. They will have the same denominator. We can just keep the denominator and add the numerators. So we're going to have now square root of 1 plus a plus square root of 1 minus a over square root of 1 plus a minus square root of 1 minus a. Okay, perfect. Now we have here 1 over a plus, we can separate each one with its denominator, over square root of a squared. Okay. Now the question is, if a is less than 0, then what is going to be square root of a squared? If we say square root of a squared is equal to a, that will be totally wrong, because we are assuming that the square root of the square root, which the index is even, can produce a negative number, which is impossible. So that means that the square root of a squared will be equal to absolute value of a. Why? Because a is negative. We can't say it's just a. It has to be absolute value of a. And the absolute value of a, in this case, we know that the absolute value of any number, whether it's positive or negative, always produce a positive number. So if a is a negative number, because it's less than 0, that means minus a is positive. So that means absolute value of a will be equal to minus a. So that means square root of a squared will be equal to minus a. So we can simply then substitute where there is a square root of a squared by minus a. And the other question is here. So how do we work it out? How do we multiply this expression times this expression? Okay, perfect. Why don't we start by rationalizing the denominator? Okay, rationalizing the denominator, we're going to have square root of 1 plus a plus square root of 1 minus a over the denominator. So since they both have index 2, so we can multiply by its conjugate. So its conjugate in this case, it's gonna be a similar expression, but the main sign changed. If it's positive here, negative. It's negative, positive. So since we have a negative, then it will change to positive. Or we're going to have 1 plus a plus square root of 1 minus a over square root of 1 plus a minus square root of 1 minus a times 1 over a. In this case, square root of a squared will produce negative a, as we saw. So we're going to have minus square root of 1 minus a squared over a, instead of just using 8 minus a, which is correct. So they have the same denominator. We can keep them as one denominator. Can keep just a as the one denominator. So we have this approach. Now, if we multiply this expression here, this expression is similar to this expression. So this, for the first one, the numerator reminds us this property of a plus b squared is equal to a squared plus 2ab plus b squared. While the second one, it's difference of 2 squared. Here is positive. This is difference of 2 squared, which says a minus b times a plus b is equal to a squared minus b squared. Okay, having that into consideration, then we can apply here. Okay, then now we have this will be equal to the first one squared, which means square root of 1 plus a squared. Now the thing is, we have 1 plus a squared. Can we eliminate the square root of 1 plus a? That's what we're going to discuss. Plus 2 times square root of, we have a times b according to the formula. And since they are 1 plus a and 1 minus a, it's the same as b here. So we're going to have 1 minus a squared plus square root of 1 minus a all squared over. Now, in the denominator, we have the conjugate multiplying one another, which means we are in the presence of the difference of 2 squared. Then we're going to have the first one squared, which is 1 plus a squared minus 1 minus a squared. Okay, times 1 minus square root of 1 minus a squared over a. Now this one, 1 plus a, if we check, a is a negative number. If there was no condition that a is also greater than minus 1, then we will have a problem here. We will take this with absolute value, because 1 plus a then wouldn't be a positive number. But since a is greater than negative 1, that means even if we put negative 1 here, we have 0, so nothing affects. So we can simply simplify. So we have 1 plus a and 1 minus a, and this a and this a, they are symmetric, so there will be 0. So we're going to have these two cancelled. Then 1 plus 1 will be 2. So this means that we're going to have 2 plus 2 square root of 1 minus a squared over. Now here we can also simplify. This negative enters, then a negative and negative becomes positive, so we have 2a, negative and positive becomes negative, then we cancel the 1, so we're going to have here 2a. So if we factorize 2 here, then if we factorize 2, we're going to have 1 here and this expression times 1 minus square root of 1 minus a squared over a. These 2 and these 2, they cancel out. We have difference of 2 squared again, which means we're going to have 1 squared minus square root of 1 minus a squared all squared over a squared. Now we can simplify this negative enters. We have 1 minus 1 plus a squared, because this negative and negative becomes negative. So 1 and 1 cancel, a squared over a squared, simplified, and we are left with 1. So that means our solution for this simplification is 1. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.